In episode 46, titled Fix Broken Filters and Stale Data, Source Validation Structure Changes, the central idea is that filters are a trust contract between the report and the reader. When a filter breaks, people do not just lose a convenience feature, they lose confidence that the numbers are stable and that the report can be used for decisions under time pressure. In many organizations, a filter failure is remembered longer than the fix because it creates the sense that the system is fragile. That is why this topic is treated as part of reporting integrity, not as a minor user interface problem.
The fastest way to restore clarity is to confirm the symptom by reproducing the behavior in a controlled, repeatable way. A report might appear broken because a filter no longer changes the view, because it returns empty results, or because it returns a partial slice that looks plausible but is wrong. Reproduction matters because different failure modes point to different causes, such as a missing field, a data type shift, or a refresh that did not complete. Once the symptom is reproducible, the investigation stops being opinion-based and becomes evidence-based. After the symptom is confirmed, attention should shift to whether the data refresh completed successfully and whether it did so recently enough to match expectations. Stale data often looks like a filter problem because the filter responds, but the underlying data set has not advanced, so users keep seeing yesterday's picture no matter what they select. A refresh might also complete partially, leaving the newest partition missing while older partitions remain, which creates confusing gaps that look like filter bugs. When refresh timing and data latency are known and visible, it becomes easier to separate a real filter logic defect from a pipeline freshness problem. A practical next check is validating that the upstream source still returns the expected fields and content because many reporting failures originate outside the reporting layer. If a report depends on an API response, a database view, or an exported file feed, the upstream owner can change or deprecate fields without realizing that downstream dashboards rely on them. Even when the upstream system is stable, access or permissions can change, causing missing columns or truncated results that look like no data after a filter is applied. Treating the upstream source as a dependency with its own behavior and change history reduces the urge to blame the dashboard first. Schema changes are a frequent culprit, especially when columns are renamed, moved, or converted to new data types that break the assumptions baked into filter logic. A column that was once a clean category label can become a mixed type field, or a timestamp field can change format, which can push values into null-like states that filters do not handle well. Sometimes the schema change is subtle, such as changing capitalization, adding a prefix, or altering a code list, but subtle changes can still break joins and filter mappings. Recognizing schema drift as normal rather than rare helps teams build checks that catch it early. Filter logic itself can fail even when the schema is unchanged, particularly when new null patterns appear or when unexpected categories are introduced. A filter might exclude nulls by default, and a sudden rise in null values can make the filtered view appear empty, which feels like a tool defect, even though it reflects a data quality shift. Category filters can also misbehave when new labels arrive, such as unknown, other, or an environment name that was never seen before, because the filter list and the data no longer align. The important move is to treat nulls and category drift as first-class signals because they often reveal a real upstream change that needs attention. Comparing the current dataset to a previous snapshot is one of the most reliable ways to detect what truly changed, because it turns a vague complaint into a concrete delta. If a prior snapshot exists, differences in row counts, distinct category values, and key totals can quickly show whether the issue is missing recent data, a shifted time window, or a structural change in the feed. This comparison is also useful for identifying whether the break began at a specific time, which can often be correlated with a deployment, a source system update, or a change in extraction logic. The goal is not to create a perfect forensic reconstruction, but to reduce the search space to the moment and surface area where the break first appears. Version comparison also protects teams from a common trap, which is diagnosing purely from the dashboard surface rather than from what the data actually contains. A filter that appears to ignore selection might be receiving identical values across time windows due to a processing error, making every filtered view look the same. A filter that returns empties might be interacting with a join that is now dropping records, so the underlying dataset is smaller than expected even before filtering. When the current and previous snapshots are examined side by side, these possibilities become visible without relying on guesswork or user anecdotes. A renamed field scenario is a clean way to practice root cause thinking because it shows how a small upstream change can create large downstream confusion. Imagine a report that filters by region, and overnight, the upstream system standardizes naming and changes the field to site region, while also changing the values from shortcodes to full names. The report still loads and some visuals still render, but the region filter either shows no options or shows options that no longer match the underlying join keys, producing empty charts when selected. In that situation, the broken filter is not really a visualization problem. It is a mismatch between expected structure and delivered structure, and the fix must happen at the mapping boundary.
The durable fix in cases like this is to update mappings and transformations, rather than applying manual one-off patches that only work for a single view or a single day. A manual patch might hard-code a value or rename something locally inside the report, which can hide the symptom while leaving the pipeline inconsistent across other artifacts. Mapping updates, on the other hand, restore alignment at a shared layer, so every downstream report receives the corrected field name, type, and value standard. This approach also supports reproducibility because the organization can explain what changed and where the correction was applied, instead of relying on hidden edits that only one person remembers.
Once the technical correction is made, the reporting system still needs communication because trust repair is partly social and not only computational. Stakeholders who rely on the report need to understand whether numbers changed because new data arrived, because a field definition shifted, or because a prior view was incomplete, and those are different stories with different implications. A short, plain explanation of what changed, when it changed, and which reports are affected prevents people from filling the gap with suspicion or folklore. Communication is also a governance tool because it creates a record that can be referenced later when the same question arises in a review or audit. Monitoring is the long-term defense, especially for stale refresh cycles that can quietly degrade dashboards without causing an obvious hard failure. A refresh job can begin to run late, skip a partition, or fail silently in a way that still produces an output file, and dashboards built on that output will look fine while drifting further from reality. A good monitor watches freshness indicators such as the newest timestamp present, row count trends, and basic completeness checks rather than watching only whether a job returned a success flag. When freshness is continuously observed, stale data becomes a detectable condition rather than a surprise discovered by an executive in a meeting. Fix validation should go beyond a single happy path click because broken filters often have edge cases that only appear across different time ranges, categories, and combinations of selections. A filter can appear fixed for the last 7 days, but still fail for a quarter view if older data uses a different code set or a different timestamp format. It can also fail when multiple filters interact, because the combined condition may expose null handling or join gaps that a single filter does not reveal. Testing across multiple ranges and slices turns the fix into a confidence-building event rather than a fragile workaround. Over time, a checklist mindset helps teams respond consistently, but the checklist should live as a stepwise narrative rather than as a rigid template. The investigation begins by reproducing the symptom, then verifying freshness, then confirming upstream fields and schema, and then examining filter logic for nulls and new categories that violate assumptions. The next phase compares current versus previous snapshots to pinpoint what changed and when, and then applies a shared mapping fix that restores structural alignment for all downstream artifacts. When the routine is repeated often enough, broken filters stop feeling mysterious and start feeling like a known class of problems with a predictable path to resolution. To conclude, one monitoring habit worth starting today is to treat dataset freshness as a visible metric that travels with every important report. That can be as simple as consistently exposing the newest available data timestamp and a basic completeness signal, so consumers can immediately tell whether they are looking at current information or a lagging snapshot. When that habit becomes normal, filter complaints become easier to interpret because the first question is no longer, is the report broken, but is the underlying data current and structurally consistent? That shift in posture protects trust because it makes reporting behavior explainable even when the environment changes. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.